Good afternoon, everyone. Welcome back to our Java Level 1 class. So today is our third class. So we will continue. Last week was Thanksgiving. So the week before last week, last class, we learned the primitive types. And then we understood that binary data use the least resource because it only uses 1 bit. And then when we talk about other data types, we know that like bytes, 16 bits. So today we just dive into that and learn a little bit more. So let me share my screen. You do not actually run too much in this concept when you program it. It is just a concept. So what is a bit? What is a byte? So you say a bit. It's actually how computer, tell the things. It's like electricity. You have electricity or not. So that means for the switch is on or off. So computer can memorize that. If it's off, then it knows that's off. If it's on, it knows it's on. So there are only 2 states, on off. So it is exactly a Boolean value, true or false, right? But then why do we need to learn byte? When you read this paragraph, I want you guys to read this paragraph. Can you tell me why we need to use byte? Byte is just more bits in it, right? Actually, 1 byte is 8 bits. So why? There's no wrong or right answer. Just take a guess. Help us understand the programming, why? Or we say understand the computing more. Any ideas? Emily, can you take a guess?
Are you trying to like the difference between bit and byte?
Yeah, but why we need to use a byte?
Maybe because byte has can store more bits.
Okay, that is true. But we need more from it. Roland. So take a guess why. Roland.
I'm not really sure.
Okay, so let me put it in this context. So if you only have bit, right? So what you can know is just true or false. So if I wanted to have alphabetic A, how does the computer know it is alphabetic A? Right? If you type in a word, let's say Java, how the computer knows that, right? So that's why computer tries to cut it. So you see every 8 bit, it treated as a unit, and the 8 bit. So you see how much information it can store in the 8 bit. So it makes that unit with a meaningful result. Say if you do GPS, right? How can my phone understand my position. It is the code comes from the satellite that you decode it, and you will see, okay, every second the information I received will be a unit. So there are like millions of combinations, possibilities in it. So a combination like that, it means it's okay, 10.5. A combination like that, you will see this 10.10, 10.9, something like that. So if you wanted to see what is letter A, so then you use a byte, so you store a sequence there. If this sequence is, let's say, 0101, that is A. So 0100, that is B. So that, you know, that makes you know, your computer powerful to understand the complex stuff. So that's why you use byte, and the byte actually in computer we call it what? They call it a word. I think I have a slide there. So a byte is a unit of data that is 8 binary digits long. So that means 8 bits. So if we have a binary value of 110, so what is the value of the number it represents? 110. Okay, so how can you come up with 15? So if it's 0, then it is 0, right? If it is 1, then it will be 1. So if it is 2, then it will be 10. So you are using 2 bits now, right? 10 will be 2. 11 will be 3, right? 11 will be 3. And then 100, what is that? 100, it will be 4. Okay. And then 101, it will be 5. Right? And 110, it is 6. So yes, exactly, Adrian. So you have that. Can you type that information in the chat to everyone? So that's exactly what it meant. So if you do this number in a binary here, and in decimal, it will be 6. Okay. So now you say you store 110, you use 3 bits, and you have number 6, right? So one binary stores the value 0 and 1, 2 numbers. 2 binaries will store 4 numbers, right? Just keep on. So that is why. So if you see there are 3 bits is used, that means the cube of 2, right? So how many number you can store using 3 bits? It's 8, right? Because it's a cube, 2's cube. So let's figure out what's the largest number value that a byte can hold. What is the largest value? Can you guys tell me? Okay. So then what is that value, Adrian? What is that value? Can you tell me the number? And then let's come to Java primitive data types. Okay. So what is that? So when you get into, when you see a byte, that's the value it stores. Why it only stores 128? Because you need another bit to store the sign, if it's a positive number or a negative number, right? Let's see, this is how a short number can be. If it's 16 bits, so that means 2 bytes. So this is the number it can store. That's the maximum and the minimum. So you need to understand that. So if you create a variable, if you use a short, and then you need to use this variable to store a value, let's say 33,000, then your code will give you problem because the maximum value a short can store is this much. It's that much. Hopefully you understand that because you guys are high school, so that's why I talk about these slides. So Java batch data types. So why I talk about the batch? Because when you write the Java code, okay, so when we write the Java code, we just open my Java. If I write Java code, actually the computer does not understand your Java code at all. It does not. Java has to be compiled. When it is compiled, it becomes the bad code. Okay, a bad code, that means 8 bits. So that's a word. So it's converted them into the bad code, then the computer can understand it. So the computer just goes through, okay, running this bad code, and then it computes it and it gets the result, and then you just interpret that result and make it something that the human can understand. Okay, so Java batch data type, that it is 8-bit signed. Okay, so understand this. And why when you go to negative, you can go to negative 128, but the positive, you can only go 127 because you do not have any -0, right? Okay. So half a byte, that means 4 bits, is called a nibble. So in some systems, the term octet is used for an 8-bit unit. That means byte. Okay, so they call it a octet. In many systems, like our Windows, 4 8-bytes, okay, or octets forms a 32-bit word. So you see our old Windows system, if you guys still have memory, and if you know that you use a Windows system, we see it is a 32-bit system because it stores the stuff in 4 bytes. Okay, so it's in the 4 bytes unit, so it's called a word. Okay, in such systems, the instructions or length are sometimes expressed as a full word. That means 32 bits long. This is good enough to cover all meaningful stuff. You can make things out of it. But sometimes, you know, when it gets complex, it is not enough. It is not enough. So that's why nowadays computer Windows system is 64 bits. So it can store a lot more information. 64 bits. Okay. Data sizes are usually measured in bytes. Okay. And the broadband speeds are measured in bits. So in telecommunication, the bit rate is the number of bits that are transmitted in a given time period, usually a second. So if you go to the network, you will see it's 1 megabit per second. And you will see, okay, now there's 1 megabit per second is not correct. Because if you come to our STEM center here, our network like is about 700 megabits per second. Okay, so when you talk about the network computing speed, it is bits. So a byte is usually an uppercase B and the bit is a lowercase b. So if it says MB, okay, that is megabytes. But if it says M lowercase b, that means bits, okay? So just be careful about that. If you talk about the storage, how many megabytes you need, how many gigabytes you need to be aware of those, okay? So there's one exception to this, of course, and it is the symbol for kilobit, which is KB, or lowercase, okay? I'm not going to quiz you guys, okay, on this one, not going to. So this is a table, and you already reviewed last class in the primitive data type. You see this is the primitive data type. You see what's the storage we need for Boolean. We just need 1 bit. So I give you guys a quiz. Which data type uses the least resource? Of course, it's Boolean. Okay, then you come to see 1 byte, right? So then 2 bytes. Okay, so I want you guys to look at that shorter. You see also 2 bytes. Okay, so you need to be aware of those. And let me quickly talk about the characters as well. When we deal with Java, character is different from text. Okay, character is just like a letters, what you type in, but the letters can also be text. So you see, how do you define a character? A char data type. Char is a character. So it is a 16-bit Unicode character. Okay, so it is noted like that, or 0. Oh, that's its minimum value. This is the maximum value. That is this one. Okay. So when you say you create a variable, let me give you the example. This is a variable called letter A. And if it's a character, you need to use a single quote. Single quote, okay? So we will come back to talk about the char more next class, especially its value expression. And then you may ask me why it is written in that way. Okay, this is not a decimal, okay? So it's more than decimal. So you use like it's actually 16. You use 0 to 9, that's 10. Then A, B, C, D, E, F. Okay, to log it or to remember a character. So that's why it is 16 unit. It is 16. So you need to remember this. Okay, so what is the difference between an init and a long? And I think I'm not going to quiz you guys on this at all because we just finished that. Okay, so let's do this one. Generally say data types, how can you convert? So generally speaking, it does not allow a big type of data. So you cannot convert a long data type to a short, okay? So you cannot be assigned to a smaller type. So the table can tell us which one is big, which table, this table, okay? Which one is big. So you cannot assign that because the smaller ones cannot hold a value of a big one. So when you say this is a long variable, when you create that variable, the computer will automatically allocate. Okay, it's a long variable. They will automatically allocate 8 bytes of resource, memory to this variable. Okay, so that is why. So you cannot assign a bigger data type to a shorter one. So by default, the system considers a fractional value as double. So if you write something like a 3.4, Java will treat it as a double value. If you try to assign a fraction value to a float variable, we may get a combination error, the compiling error, okay? So what is a combination error? So it is preferred to use a double variable rather than a float. So, okay, remember this when you do it in Java. So how can I let me see, goes to Java. Let me see what I created last week. Okay, I do not have that here, the code. So how can you create a variable for a floating variable? How do you do that? You will see this float x equal to 2.3f. You have to see that. If you do not have the f here, you will get a problem. It will treat this as a double value. Okay, remember that. That's what it meant. That's what it meant. All right, so now let's learn Boolean. So Java has a Boolean data type which can take the value true or false. The Boolean type is declared with the Boolean keyword. The Boolean expression, pay attention to this. So if you go to do computer science AP class, so let me go back to that slide. Okay, you will see you are tested on that Boolean expression. So you have to be aware of this. So what is a Boolean expression? So a Boolean expression is a Java expression that returns a Boolean value. It will return true or false. So let me just quiz you on some of those, or let me just teach you some of those. So let's do this. So you see, you create a variable x equal to 6, y equal to 11. Both are integers. You see, this is a Boolean expression. So if you run this, what will be printed out? Can you tell me? What will be printed out? Adrian, what will be printed out? Okay, good, pattern, that's good. So false will be printed out. So we will discuss more about Boolean expression when we learn condition. So be aware that it is a topic of AP computer science test. And remember that you see this is in the Boolean expression. Right, so I want you guys to spend 5 minutes on this website. I'm going to test you guys on this one. You do not need to get into the bitwise operator, okay? So let me go to that website and I will tell you where you need to read. So here, arithmetic operators, assignment operators, okay? You need to read that. Comparison operators. So you need to, read up to this level. Then I will start to quiz you. I think it should be straightforward to you guys. In the logical, when we talk about the condition, we will come back to learn more about this, but you need to be aware of that, okay? If you have time, you can read to here as well. All right, go ahead and then read this website. And then I will come back to test you. Yes, you can do floor division. All right, so let me test you guys, okay? Doing a small quiz on these operators. I think this should be very straightforward. So, all right. So the first one you see, if you run this, and then now you run this one, can you tell me what is the y value now? Can you tell me what is the y value? Let me get in the student to answer it. Yes, Adrian, you are right. Y is 7, and because you use plus plus here, right? So what does it mean? What does it mean? Plus plus, Adrian? Can you speak up?
It increments the variable by 1.
Okay. So what is this value? Let me get a student to answer this one. Stephen, what is this value?
I'm not sure.
Who knows it? Chris?
I don't know.
Roland, what is this value?
I'm not sure.
Who knows it? Jack?
I'm not sure, but is it 6? Sorry, is it 7?
Okay, this value is not 7 because you see here. Okay. X equal to 6. Let me just print this out. So let me make sense out of this. I want to spend a little bit more time with you guys on this one. All right. So let me just think I have another file I may be able to use. Let me just use this one. Let me just go to use this one. All right. So let me just print out system.out.print. And I will print out a Z. Let me see what is this value. So let me just comment out all this code. All right. So let me save my code and run it. You see, Z is 8. Why? Why it is 8? Because you see X is 6. But when you do this one, you increase X by 1. Okay. So now X becomes 7. So that's why Y is 7. So X is 7 already. And you then do this one, you increase X again by 1. So now X becomes 8. So they get X value. So that's 8. Right? So you are increasing X, okay? You are increasing X. So that's why. All right. So now can you tell me what is the X's value now? Can anyone tell me? Yes, X is 17. Why? Because here you see you use this operator. This operator increase X by 1. So X was 8, now it's 9. And then you have this operator here. That means X equal to X plus this one, 9. X was 8 plus 9 is 17. You assign it back to X. So that's why X is 17 now. Any question on it? So let me just print this one out. Okay, put it here. And then let me just print it, X out. And then you know what is X. X is 17. Any question on this one? Any question? Okay, if there's no questions, then let's move on. If you have no question, you really need to, do this quiz more. So let me get someone to help me read this, okay? So difference between plus plus X and X plus plus. So can I have Chris to help me read this slide? Chris.
Difference between x plus plus x and x plus plus. Both plus plus x and x plus plus are used to increment variable x by 1. The prime difference is that plus plus x, for example, pre-increment operator uses the principal change then use, while x plus plus post-increment operator use the principal use then change.
Okay. So if you use x plus plus, that means you use x first, then you increase x. Okay. Plus plus x, that means you increase x first, then you use x. So when you use it, when you increase, so the value changed. Here the value do not change, but afterwards it changes. Okay. Afterwards it changes. So be aware of those. So x plus equal to y. Now I want you to pay attention to that. Of course, this operator can be expanded to minus and the division and the multiply as well. So can I get Adrian to read this slide? Adrian.
X plus equals y. It's one of the assignment operators. It takes the value of x, adds it to it, and then stores the result of x plus y back into x. X and y must be of the same type.
Good, thank you. So when you do this, it requires x and the y are of the same data type. Okay, they are of the same data type. So now I have some quiz here, okay? So tell me what will be this value? What will be this value? Let me ask Emily. So what will be this value? Do you agree? Emily says it's 4. Jack, do you agree?
I agree.
Okay, Patton, do you agree?
Yeah.
Okay, so Emily, what is the value? Okay, it's 0. And why it is 0? Let's go back. So I ask you guys to read this. What does this mean?
Wait, never mind. It is 0.
Yes, so it is 0. Right, so you assign 6 to t. So now what is b's value? What is b's value? Can you tell me? Can anyone tell me what is b's value? Yes, Adrian. B is false. Okay, then this is in a Boolean expression. Now what is b's value?
True?
It is false. Why it is true?
Oh, never mind.
Yeah, z is 0. 0 larger than 3 makes it false. Because you use and, that means if this is false, then the whole thing is false. So that's why it is false. Okay, so now what is this value here? Why it is true, Adrian? Can you explain it?
It's 4, so one of the statements has to be correct for the entire thing to be true.
Yeah, because you use or. This is the logical or. Okay. Logical or, that means either side is true, then the whole thing is true. This is a false, but this one is true. This one is true. So that means the whole thing is true. So you use or, that means if either one is true, then the result is true. Okay. All right. So let me see the last slide for last week's material. I want you guys to do this homework. I will put this in the classroom. So if you guys have access to the classroom, you need to do the homework. So let me give you the classroom code for you guys. Not sure if you guys have this code or not, but let's do that. So this is the classroom code, okay? Want you guys to do the homework. So join this class room. All right, so let me get today's material. I think I have a lot. Yeah, no, I'm doing the class, so you're asking to see. So, okay, so I'm not going to review this because it's fresh to us. So let's just move on. Revisit data type charm. So we need to start from here. If we cannot finish today's class, that's okay. We will continue next week on it. So chart data type is a single 16-bit Unicode character. And then we will see why it is 16-bit and why we see it's a Unicode. So the minimum value is this, and I showed you just a little while ago that this is the maximum value. Okay, for a chart you can store. Chart data type is used to store any characters, examples like this one. Okay, I showed you before. So why do we use Unicode? Why? So Unicode stands for Universal International Standard Character Encoding. Right? Why we need it? Because it's capable of representing most of the world's written language. For us, we think, we do not need to use 16 bits because what we have is just 0 to 9, then 10 numbers, right? Then A to Z, that's 26, right? So then if you plus the capital, then 52 plus 10. So you just need a 72. Then you can store all the alphabetic, numeric stuff, right? So it's enough, but it's not enough for a lot of other countries. So that's why we need to use Unicode, okay? So before Unicode, there were many language stands. So this is the one we use, and I think you may be very familiar to it. So it is called ASCII2, right? It's the American standard because that's good enough for the United States. Okay? And for Chinese, they use GB and the big file, another standard. And we will talk about why. So back in the days when the Unix was getting invented, characters were represented with 8 bits. And you remember 8 bits, how many numbers you can store? 128, right? 128. So it's 1 bit, 1 byte of memory. So it's good enough for you to do the ASCII table. Right? So ASCII table 128 is good enough. You see, here you from 0 to 127. So you not only can store the numbers, and the letters, but also you can store all the punctuation symbols and the spaces that you see here. They can store, so they store a lot there. It's good enough for English. So this is the OSCAR chart. But okay, when you come to the Oriental language, then 128 is not enough anymore. It is not enough because for Chinese, you know, you have more than 1,000 Chinese characters, right? So then 128 is not enough. It is not enough. For English, it's good enough. So that's why we need a standard to store the characters. All the characters are available in the world. So we need a new standard. So that is called a Unicode standard. Okay. I'm not going to talk about the disadvantages. I already mentioned it. So to solve this problem, a new language standard was developed. So that is a Unicode system. So in Unicode, characters holds 2 bytes. Okay. So Java also uses 2 bytes for characters. So you have enough memory to store all the languages in the world. And so UTF-8 is by far the most common encoding you will come across on the web. So the great thing about UTF-8 is that the first 128 code points are exactly the same as ASCII. So the Unicode system really does not affect us. So we still can use the current keyboard. Okay, the current keyboard is good, even though you use in the Unicode system, like a Windows 8 and Windows 10. Okay, so it's good there because the ASCII, the first 128 is identical as the first 128 characters in the Unicode. But if you wanted to store that value, okay, you see the hexadecimal numbering system is used as it's a short way to reference large numbers. So that's why you see when we talk about a chart, you have the slash, then the U, then you use 000, right? And the larger ones that are slash U, then F, right? So that's a 2 bytes system to store, okay? To store all the characters, So the chart data type. So hexadecimal uses the decimal numbers and the 6 extra symbols, A, B, C, D, E, F. So then you see you have 16 as the units, right? So the maximum number, one number is F. And the decimal, its value is 15. So it's in a 16 unit, okay? So a 2-byte Unicode chart value in a hexadecimal numbering system ranges. The lower value is this, okay? So this is 2 bytes, okay? And here, that's the highest. So the total characters it can hold is 16,536. So that's a lot. That's good enough. Okay. So now let's come back to chart. So a chart is a letter, a digit, a punctuation mark, a type, a space, or something similar. The chart literal is a single one character enclosed in a single quote marks like this. So when you load the Java data types char, it's like that. We don't have it in Python. If you already load the Python, okay, using a single quote, so you get in correct. Some characters are harder to type. For this, Java provides an escape sequence. So that's why you see the backslash. Sometimes, you know, it's special in Java. So the backslash followed by an alphanumeric code. For instance, backslash n, what does it mean in Java? It means a line feed. It's a line feed. It's a new line character. So when Java read this, then Java will go to start from a new line. So that is what it meant. And then backslash t is a tag character. Okay, so you can written it out. So I want you guys to spend 5 minutes on this page. So pay attention to its letter, its digit. Now, and how can you get the integer value of a character? Okay, how can you get that? So can you go to this website and read it? All right. Pay attention to these methods. All right, so I also give you these 2 lines of code. I want you guys to run it. So let me just put it here. Now you see you have a character. Okay. So character C and the character 5. And then you ask if it is digital or not. So let me save it, and then let me run it. So I get a false and a true. C is not a digit, 5 is. So that's why it prints out true, and here it prints out false. Okay. Right. So you see those methods, right? So next one. So the Java character get a numerical value returns the integer value that is a specified Unicode character represents. So if the character does not have a numerical value, then -1 is returned. So if the character has a numerical value that cannot be represented as a non-negative integer, for example, a fractional value, then -2 is returned. So what does it mean? Let's do this. Get a numerical value. Let's do that here. So change this. Change this. All right, let me save it. Let me run it. That's the numerical value it represents. And this will, let's go back to this chart. Can you find the C? Okay, A, B, C, D, C. All right, this is C. So C's value, you see, it's 12. Why it is 12? Because the 0 character is value, numeric value is 0. 1 is 1. When you get to 9, it is 9. Then the lowercase a will be 10. Lowercase b will be 11. So lowercase c will be 12. And then you will see what is in the capital C. You can run it. Then you just add 26 to it, right? All right, you see, you just add 26 to it. But you see why? It's not. So this one is very confusing, right? So you needed to come back to read it. So I want you guys to go to this one, get numerical value character. You do not have it here. So I want you guys to read this. Let me give you this website. So you want you guys to read more on this one. And then we will finish it for today. So go to read this website, just go to the method, get a numerical value. Okay. Get a numerical value, see what it meant. Click on it. That's what it meant. Okay. All right. So I want you guys to be aware of this. Let me then stop here. So this is get a numerical value. This one. Okay, so next week when we come back, we will start from here. I want you guys, read that and pay attention to it, so you know what we will got. Okay, what we will got. So see the difference. You see, get numerical value and then convert it to an integer. What's the difference? So I want you guys to be aware of those. And then next week we will come to learn numbers. What are numbers? I think those are all very straightforward, simple stuff to you guys if you are in the high school. But it's also very important because they are primitive data types. So let me stop here. Again, I will give you the homework. So now let's go to read the homework. So many people outside the US uses Celsius degree for temperature. Write a Java program to convert the temperature from Fahrenheit to Celsius degree, the input value of degree in Fahrenheit is 212. So what is the output? Right? Also, please find out what is the real number value is for a binary value of 101101. So you give me the answer to that. All right. So this is like right now, if we say this for elementary school students, but you just write in the Java formula. Okay, Java formula. Using Java to give me a formula. So you can get the result. So that's very simple, right? So let me just copy this in the chat window. And I also put it in the classroom and I want you guys to do it. So we will review the answer next week, okay? All right, that's what I have for today. Thank you, guys.
Bye, thank you.
Any question? If you
Bye.
have a question, you
Thank
can
you.
say yes.